Hello students, in this session we will discuss about linked list concept. A linked list is a collection of elements called nodes and order is maintained with the help of links, also known as pointers. Now such a representation is known as linked list. Now remember, actually, in linked list concept, every element is represented as a node, and these nodes are interconnected with help of links, also known as pointers. Now, observe the diagrammatic representation of a linked list. Now this one. Now it shows diagrammatic representation of a linked list. So when we observe this format, here three nodes are available. Start and end are two pointer variables that points to beginning and ending nodes of the list. Then, what are the different types of linked lists? Now based on the number of parts in a node and then the way of establishing links in between the nodes, linked list can be classified into four categories like single linked list, double linked list, circular linked list, and header linked list. So here first one, single linked list. First one basic thing is a linked list concept, hence every element is represented as a node. In case of single linked list, every node is divided into two parts like info or data part and link part. So here data part stores information part of the element. Link part stores address of the next node. Now observe. Now this one diagrammatic representation of a single linked list. So when we observe this format, every node consists two parts. Here the data parts are 59, 38 and 64. Here the link part stores address of the next element. So for node 1, the next node address is 2. Hence 2 is stored in link part. Now there is a link from node 1 to node 2. In same way, now there is a link from node 2 to node 3. For node 3, next node is not available. Hence, link part of the last node is filled with a specialized pointer known as null pointer. Here null pointer is indicated with a cross mark symbol. In addition to this, here we use two explicit variables, start and end, that points to beginning and ending nodes of the list. Now such a representation is known as single linked list. Now the way of defining an abstract data type for single linked list. So when we go for an abstract data type, it consists instances and operations. So here linked list point of view, instances are, it is a finite collection of 0 or more elements, and these elements are linked by pointers. The possible operations are creation, display, insertion, deletion, count, search, etc. Now To implement these operations, so here we specify the basic operations on the linked list as creating a list, traversing the list, insertion of a node into the list, deletion of a node from the list, counting number of elements, searching for an element, etc. Now, to implement these operations in linked list point of view, first we design node structure format. For this, here we use self-referential structure concept like typedef struct list open brace. Now we place these two members as int data struct list asterisk link. Now end curly brace. Now this entire data type is referred with a new name as node. Now for this data type, we can simply create the variables as node asterisk start. Initially elements are not available, hence it is filled with null pointer, comma asterisk end equivalent to null. Now these are initial constraints. Now based on these constraints, now we go for first operation, creating a list. So it refers to the process of creating a single linked list. So in creation process, we create number of nodes and then we establish links in between the nodes. For this, initially elements are not available, hence the two pointer variables start and end are set at null pointer as, so this one node asterisk start equivalent to null, comma asterisk end equivalent to null. Now observe algorithm process. So algorithm creation, this procedure creates a single linked list with the specified number of elements. Now observe these steps. Step 1, repeat while true, since it's a repetition process. First read an element as x. Now if x equivalent to minus 999, then return from the function. Otherwise, first allocate memory for a new node. When memory is allocated, now in node point of view, two parts are available like data part and link part. Now data of new is filled with x, link of new is filled with null pointer. Then we check whether the list consists any elements or not. If elements are not available, then the first new node becomes start and end nodes of the list. Otherwise, if already elements are available, now we establish links in between end node and new node as link of end is filled with new and then end is shifted to new. Here the inner comparison completed. Now outer comparison completed. Then and repeat. So this process is repeated until we submit one element as minus 999. Now whenever we submit this element, now we return from the function. So in such a way, it is possible to create a single linked list. The next operation, traversing the list. A traversing operation refers to the process of visiting every node of the list exactly once. Now to implement this operation, here we design an algorithm like algorithm display. So this procedure is used to display the elements of the single linked list from the first node to last node of the list. For this, step 1, first we check whether elements are available or not. If elements are available, then only traversing is possible. So if start equivalent to null, that means elements are not available. Hence we print a message as single linked list empty. Else, if elements are available. Now, first we set a temporary variable that points to start node. Now is a repetition process. Repeat while temp not equivalent to null. So if temp not reaches to null pointer, now write data of temp. Now temp is shifted to next location as temp equivalent to link of temp. Now and repeat, repetition process completed. Now and if, comparison completed. Now step 2, return from the function. Now observe this example. Now assume this one initial status of the single linked list. Now when we apply display operation, here the procedure starts by visiting from first node to last node of the list. Hence it accesses the data part of every node. Now single linked list elements are 59, 38 and 64. Okay. Thank you one and all.